In this class we are going to see how to switch on an ordinary lamp using the PIR sensor. That means when a motion is detected in a room, you need to switch on a lamp. That is what we are going to see now. So in the last class we have seen how to switch on a buzzer when a motion is detected. But if you want to control your normal home appliances such as fan or bulb etc., high current is required. For example, if you want to switch on a fan, you need to have at least 750 milliamps to 1 amps of current and 230 volt AC, right? But your Arduino board can supply only 25 milliamps of current and only 5 volt. So by that voltage and current, you will not be able to control your home appliances. So how can you control that? By using the small voltage and current signal generated from the Arduino board, you will be switching on a device known as a relay. This is known as a relay. By the small current generated from the Arduino board and a small voltage signal of the Arduino board, you will be switching on this relay. And this relay in turn will switch on the appliances. Right. So this relay consists of a small coil which can be activated by using a low current, low voltage signal which is generated from any of the microcontroller. So when you are applying a voltage across this small coil from Arduino, this coil will be becoming an electromagnet. So what will happen? This metal piece will get attracted towards this coil. So what will happen? This metal piece will get attracted and this will move towards this side. So what will happen? This is known as a common terminal. This common terminal will come in contact with this terminal. Right? So this is known as normally open terminal. This is normally open terminal. This is common terminal. So normally a relay consists of at least a common terminal and a normally open terminal. Right? Why it is known as normally open terminal? When you are not applying a potential across this coil, these two will not be in contact. Common and normally open will not be in contact. That is why this is known as normally open terminal, because there is no contact. But when you are applying a potential across this coil, this metal piece will be attracted towards this coil, and here it will be pushed. This metal piece will be pushed across this direction, so the common will come in contact with the normally open coil. So when you are applying the potential, these two will be in contact. So if you are connecting a lamp or a home appliances here across these two terminals, that means these two terminals will be acting as a switch for that home appliances. So when these are in contact, the home appliances will be switched on. So that is the importance of using a relay. So whenever you need to switch on a high current device using a low current and low voltage signal generated from a microcontroller such as Arduino, you will be using this relay. So in the circuit we are going to add that relay. So I can search here relay in the components list. So you will be getting a relay, SPDT relay. You can drag and drop it here. Somewhere here you can drag and drop it. I'm keeping it here. So it is known as, you can zoom it little bit. So this is known as SPDT relay, that is single pole double throw relay. Single pole double throw. That means there will be a single movable contact, that is known as single pole, that can be moved across two terminals. So here you can see, when you are zooming it little bit, you can see that the common terminal is in contact with another terminal known as normally closed terminal. In the picture, normally closed terminal is not shown. So if you are having a normally closed terminal, it will be here, and by default common and normally closed will be in contact. That is why it is known as normally closed. Normally closed and common terminal will be contact by default without applying any potential. So you can see the common terminal and the normally closed terminal is contacting by default. But when you are applying a potential across this coil, it will become as an electromagnetic coil or electromagnet, and the common will come in contact with this open terminal. It will move this contact from here and it will be in contact with this. So when you are applying potential, common and normally open will be in contact. When the potential is removed, common and normally closed will be in contact. So the relay here is having 6 terminals, right? You can see this is terminal 6, 5, 1, 12, 8 and 7. So 6 terminals are there for this relay. So what are those 6 terminals? You can see the picture here itself. These end terminals are used for contact or common contact, right? So the common can be connected to either this pin, 12th pin, or to one first pin. These two are used for contact or common terminal, right? Then the next two terminals are the terminals of the coil. Which are the next two terminals? Terminal 8 and terminal 5. Terminal 5 and terminal 8, it is nothing but the contacts for the electromagnetic coil. So that when you are applying a voltage across this coil from the Arduino, this will be, the electromagnet will be activated. So these two pin, terminal 5 and 8 is the coil terminals. Then terminal 6 is nothing but normally open terminal. The same as this coils. The terminal 6 is nothing but normally open terminal. Terminal 7 is closed terminal. So it is known as normally closed or NC. This is known as normally open or NO contact. So this is NO, this is NC, and these two are common terminals, and terminal 8 and terminal 5 is the terminals for the coil. So now when a motion is detected in the PIR sensor, pin number 13 will be activated. So pin number 13, I am going to connect it to this terminal, that is terminal 8. So when the motion is detected, signal will be generated here. This is connected. I am connecting it to the one end of the coil. Other end of the coil, I am connecting it to ground. I am connecting it to ground. So whenever a motion is detected, the coil will be energized because one end is connected to ground, other end is connected to 13, and when this will be activated, when this pin will be made as high when motion is detected. So when motion is detected, coil will be activated. Next, what you should do, you need to have a lamp and a power supply connected. So first of all, you can search for lamp or bulb. I am searching for bulb. You will get a bulb. You can keep the bulb here. Then I need to have a power supply. So you can search for power supply. You will get a power supply here, right? Drag and drop the power supply here. You can zoom out little bit. Drag and drop the power supply here. Now what I am going to do, when the relay is switched on, the lamp should get the power, or bulb should get the power from the power supply. So how will I make the connection? The ground terminal of the power supply I am connecting directly to the lamp, right? And the positive terminal I am connecting to the common terminal of the relay. Positive terminal I am connecting to the common, and normally open contact I am connecting to the bulb. So what will happen? Ground is directly connected to the lamp. Positive terminal, that is the positive terminal of the bulb or the power supply, that will be connected to the common terminal of the relay, and normally open terminal, that is this terminal. This is a normally open. You can see here, normally open terminal of the relay, that is this pin, that I am connecting to the lamp. So what will happen? Whenever the relay is energized, common will come in contact with normally open. When common pin is coming in contact with normally open, whatever power you have, whatever voltage you are getting from the power supply will be connected to the common terminal, and through the common terminal that power will be going to the normally open. Why? Because when the relay is energized, common and normally open will be coming in contact. So this power will go through the common to the normally open and the lamp will be switched on when the relay is on. Otherwise, the common terminal will be coming in contact with the normally open. So these two will not be connected. So it will be open circuit and lamp will not be switched on. So this is how the connection. Then I need to configure the voltage in the power supply. So you can click on this power supply. By default it will be 5 volt. Let us change it to 12 volt. I am connecting a 12 volt bulb here. Right. So I have configured the power supply. Now what will be the code for this? Code remains the same. What is the code? I am reading digital pin 2. If the digital pin 2 is equal to 1, then built-in LED should be made as high. If digital pin 2 is 0, built-in LED should be low. So here, what is connected to built-in LED? Built-in LED pin, that is pin number 13, it is connected to the relay. So when the built-in LED is high, relay also will be switched on, because pin number 13 is connected to coil of relay, other end of the coil is connected to ground. So when the built-in LED is on, relay also will be switched on. When the relay will be switched on, bulb will be switched on, as the positive is connected to common of relay, normally open is connected to the bulb. Right? And when will the pin number 2 get a digital one? When a motion is detected in the PIR, because that pin is connected to 2. So when a motion is detected in PIR, pin number 2 will get 1. When the pin number 2 is equal to 1, built-in LED will be high. In addition to that, relay also will be made as high. When the relay is on, lamp will be switched on. Lamp represents our home appliance. So now you can click on this code. Now we are going to start the simulation. You can click on start simulation. So by default nothing will be visible in the PIR. That movable person will not be visible here. So what you should do, you need to click on the PIR once. Then you can see that the person simulation is shown. The circle shows the simulation of the person. So whenever there is a movement within this area, you can see that the electromagnetic relay is getting activated and lamp is getting switched on. If I am bringing the person outside the viewable area or detection area of the PIR, lamp will not be switched on, because it is not, motion is detected by the PIR sensor. When I am bringing the person again to the viewable area, you can see that the lamp is switched on whenever there is a motion. Right? And when you are zooming little bit, you can see the movement of the relay also here. So when I am moving this person, now you can see the common is connected to normally open. When it is not in motion, common is connected to normally closed. You can see here. So without the lamp also you can see the simulation of the electromagnetic relay. So this is how you are developing a home automation system using PIR. So whenever a motion is detected, your lamp will be switched on, and the duration of the time for which the lamp is switched on can be controlled in the PIR sensor itself. In this PIR module, there is one potentiometer or a adjustable resistance. By adjusting that, you can increase the time at which the device is switched on. Now it is switched on for a little amount of time. By increasing the resistance or by adjusting that potentiometer, you can increase the time. So whenever there is a motion, this lamp will be on for a longer amount of time. That can be done in the PIR sensor module itself.